And welcome to Maths with Mr Amison. Today I will be talking to you about gradients. Now I know that gradients is a tricky topic and generally line graphs that a lot of students find difficult to grasp. So first of all, I want you to have a look at the two graphs that are on the screen in front of you. What's the same and what's different about them? If you look at the graph on the left, you should notice that the main difference is this one's going up, this one's going down. That means this graph here has a positive gradient and this graph has a negative gradient. When from left to right the graph goes up, that's a positive gradient. When from left to right it goes down, it's a negative gradient. Also notice that this line, for every one square we go across, if we go two squares up, we reach the line again. One square to the right, two squares up, we reach the line again. That right there is what we're going to use to calculate our gradients when we're given a line in a diagram. And similar to this one, so what's similar in this one is instead of going right 1 and up 2, we go right 1 and down 2 in this line here. So in fact the gradient of this one ends up being 2, whereas this one is the exact opposite, it's minus 2. Okay. So let's first talk about the equation of lines. In the equation of a line, we get y equals a number of x's plus a number. So m and c here are constants. They are numbers that are given. Sometimes they are algebra that we need to calculate, but generally they're numbers. And m is the gradient here. Generally, algebra represents numbers anyway, so it doesn't really matter. But m is the gradient, and that's what we're going to focus on today. Notice that m is the number that's in front of our x, and that's going to be important later on. So in each of these examples, first I'm going to show you a short video of what happens when the gradient increases from minus 2 to 2. You can see in this here, the gradient starts off at minus 2, because when we go 1 right we go 2 down, and that's a good indicator that the gradient is minus 2. What happens over time, if we increase that gradient, slowly it increases. When it's 0, it's horizontal. That's when it's 1. It's 1 across, 1 up, and that's when it goes up to a gradient of 2. So the larger the number, the steeper the gradient. When it was minus 2, when we had a gradient of minus 2, the line was quite steep downwards, but as we got closer to 0, the line got less and less steep until we got to 0 where it was flat, and then the steepness of the line increased again as you went to a gradient of 2. So in this example here, the way we can calculate gradients from a line given in a graph is to use right-angled triangles. If you think about the fact that the gradient of 2 means for every 1 square to the right we go 2 up, if we think about points on this graph that we can see where we can see the line crosses a specific point, we can draw a right angled triangle between those points. And then we can measure the sides, 2 and 3. Now our gradient is calculated because our gradient is how far up or down we need to go for every 1 to the right we go. This goes 3 up for every 2 to the right we go. So the similar triangle would be 1 to the right and 1.5 up. Or in other words, we've done our change in y direction here divided by our change in x here. So our gradient is the change in y, our vertical length of this triangle, divided by our change in x, the horizontal length of this triangle. So we do 3 divided by 2, which is 1.5 in this case. So this line has a gradient of 1.5. In this example here, you can see we've got this point that's exactly where to at an exact coordinate, and this point's at an exact coordinate that we can see. So if we draw our right angled triangle there. Then we have a height of 2 and a width of the base here of 3. But this time we're not going up 2, we're going down 2 when we're going right 3. Therefore, it's useful to label this as -2 instead of 2, because it ends up being that our gradient is negative. If we find out our value of m, then we're going -2, our change in our y direction, divided by 3, or in other words, -2/3. In the next example, there's a number of different right-angled triangles we could draw. We could draw one down here. We could move the triangle up here. Or we could draw a larger triangle here. In any one of these examples of right-angled triangles, it really doesn't matter which one we draw, because we'll get the same result. When we do our gradient, we'll end up doing our change in y, our vertical height, divided by our change in x, our horizontal distance. So we're going to do 6 divided by 8 in this case, which we can simplify to 3/4. Now if we'd used the smaller triangle, which was this one here, it would have been a vertical height of 3, a horizontal length of 4, both going positive. Therefore we would have had 3/4 straight away. We wouldn't have had to simplify at the end. So it doesn't really matter where you draw this triangle, as long as you can read the coordinates of these parts of that triangle. Now, you're not always given a straight line to calculate a gradient from. We talked a little bit about y equals mx plus c, where m is the gradient. If an equation is not in that form, then we need to put it in that form to find the gradient. So this first example, you can see, is in that form, y equals 2x plus 5, where 2 is our m and 5 is our c. So therefore our gradient will be 2. If you look at this next example, however, this is a really common question that you might see. As you can see, the m is in front of our x. So in this example, the m, x and the c have been swapped around, and that's totally fine. It just means that our m is 5 instead of 2. Our gradient is always the number that is in front of the x when we have y equals. Okay? So our m is 5. Now in this example here, you can see that we have 2y, not 1y. In a case like this, we need to make it into this form. So we need to make y the subject. So if in order to do that, in this case, we need to divide the whole equation by 2. To get y equals x plus 2.5, dividing the 2x and the 5 by 2. Now this is in this form, therefore the number in front of our x is the gradient. And because we don't have a number in front of our x, this just means 1x, therefore our gradient is 1. In this example here, we have 2y plus 5x equals 2. Now there's quite a bit that we need to do to this before we can get an answer. First of all, you can see that y is on its own, but in this case we have 2 y's and 5 x's on the left hand side, so we could take away 5x from both sides to get 2y on the left hand side. At this point you can see that we still have 2 y's and we want just 1 y, so if we divide the whole equation by 2, we get y equals 1 minus 2.5x. And again, this is a similar example to this one here, where the number of x's is on the right hand side. We're going to be careful to include the sign here. because this here represents minus 2.5x, not plus 2.5. And the key here is to remember that we have to include that negative for the gradient. So m is minus 2.5. This final example, to put together all of the things we've just done. First of all, we need to add 2x to both sides. Then we need to divide by 3. Now, often when you see a question like this, you'd be tempted to do a division like this. But we can split this up into its individual fractions. 2x add 5 over 3 is the same as 2x over 3 add 5 over 3. Now, and 2x over 3 is just 2/3 of x. So we can split it up like this, which means that our number in front of our x is therefore 2/3, so our gradient is 2/3. So, I hope that you feel a little bit more confident when it comes to finding gradients of lines from an equation and from a line graph. If you have any more questions or any topics that you would like me to discuss in some more videos, then please do comment them below. Please subscribe to see any more content that is produced, and best of luck with finding gradients.